Let's walk through this significant figures worksheet. The first thing that we're going to do is calculate significant digits in a measured quantity. To calculate the number of significant digits in a measured quantity, all we have to do is look for a decimal point. If there is a decimal point in a measured number, then we start from the left-hand side of that number and count digits starting on a non-zero value until we get all the way to the right-hand side. If there's no decimal point, we start from the right-hand side and count digits, starting with a non-zero number, until we get to the left. So let's do these following examples A through H. In example A, there's no decimal point, so we can start counting from the right-hand side. We'll start on a non-zero, and the very first digit is a non-zero. And I'll just count digits from that start to the leftmost side of that number. I count 3 different digits. Therefore, there are 3 significant figures in the measured quantity 921. In part B, 92,100, there are likewise 3 significant digits. Again, no decimal point. We start counting from the right-hand side, but cannot begin a count on a 0. So this digit and this one are not significant. We only begin a count on a non-zero number, but once we start counting, we don't stop until the end. 1, 2, 3 sig figs. A decimal point changes everything. When a decimal point is present, we start our count at the left-hand side of a digit instead. Here, the very leftmost digit is a non-zero. We can begin counting there. And again, once we start counting, we don't stop until we get to the end. So there's 1, 2, 3, 4, 5 significant digits in this quantity. In the measured quantity 0.000210, again, the decimal point tells us we have to start from the left-hand side, but we cannot start a count on a 0. So this leftmost 0 is not significant. The next digit to the right is not. The next one after that is not, nor the next one. The very first digit that we can start counting on is 2. But once we start counting, we count our way until we get all the way to the opposite end. 3 significant digits in this quantity. Likewise, in 0.00219, we start our count from the left, but only begin on a non-zero. So the 2, the 1, and the 9 are all significant, and those are the only significant figures in that quantity. 3 significant digits. In 93 million, no decimal point, we start from the right. We can't start a count on a 0, so the very first digit to the right that's non-zero is this 3. I start counting and don't stop till I get to the left, so I count 2 significant digits in 93 million. 93,000,003, however, gives me a rightmost significant digit. No decimal point, so I start there. 1, 2, 3, 4, 5, 6, 7, 8 significant digits in this value. Similarly, the presence of a decimal point allows me to start from the left-hand side and count everything right. 1, 2, 3, 4, 5, 6, 7, 8. 8 significant digits